Hello students, this video is brought to you by Southern Pathshala. MCQs on nuclei and the radioactivity. Strongest force in the nature is strong nuclear force. Option C. Atomic number of nucleus represents the number of proton, that is denoted by ZXA, where Z is the number of protons, A is the proton and neutron. They are together called as nucleons. Mass number of the nucleus is represented by number of nucleons. Difference between mass number and the atomic number, it is given by the neutron number. A minus Z is equal to N, that is number of neutrons. If Z represents atomic number, A represents the mass number of the nucleus, then the charge on the nucleus given by it is plus Ze. Volume of the nucleus is directly proportional to atomic number, that is V is directly proportional to A. If A is the atomic number, radius is given by R is equal to R naught into A to the power 1 by 3, that is directly proportional to A to the power 1 by 3. Radius of the nucleus is given by R is equal to R naught into A to the power 1 by 3. If Z is the atomic number, A is the mass number, MP is the mass of the proton, Mn is the mass of the neutron, then mass defect delta M, it is given by, so option C, delta M is equal to ZMP plus A minus Z into Mn minus M. Density of the nucleus is, it is independent of the mass number. Mass defect is the difference in the mass of the nucleus and its constituents, that is option B, that is given in this equation. Next question. Density of the nucleus is about, so that is the standard value, it is about 2.29 into 10 to the power of 17 kg per meter cube. Atoms of nuclei having same number of protons but different number of mass number, they are called as isotopes. Okay, example 1H2, 1H1, they are isotopes. Atoms of two nuclei having same number of neutrons are called as isotone. If the number of neutron is same, that is called as isotones. Atoms of two nucleus having same atomic mass number but proton number and neutron number are interchanged, they are called as mirror nuclei. Atoms of the two nuclei having same atomic mass but different atomic number are called as isobars. Among the following atoms, select the isotopes. Isotope means same element must be there. 17 chlorine 35, 17 chlorine 37. Therefore, this is isotopes. Among the following, select the isotones. Isotones means same number of neutron. If you take this potassium and the chlorine example, 39 minus 19, it will be 20. 37 minus 17 is also 20. Therefore, option A will be the isotones. Among the following, select the mirror nuclei. Okay, mirror nuclei. This is a mirror nuclei. That is number of protons and neutrons are interchanged. Among the following atoms, select the isobars. Okay, isobars. So this is an example for isobars. 6 carbon 14, 7 nitrogen 14. That is mass number is same but atomic number is different. Charge on the nucleus is always positive. One atomic mass unit is given by 1.66 into 10 to the power of minus 27 kg. One atomic mass is equal to 1 divided by 12th of mass of carbon 12 isotope. Okay, question number 24. Nuclear binding energy is the energy equivalent to mass defect. Okay, that is nothing but we are writing delta E is equal to, or E is equal to delta M into C square. That mass, it is correct. Energy required to form a nucleus starting from individual nuclei, that is also correct, and it is the energy needed to break the nucleons into constituent. Therefore, all the above answers are correct. Energy equivalent to one atomic mass unit is nothing but 931.5 mega electron volt. Mass, atomic mass unit can be determined by mass spectrometer. Neutron was discovered by James Chadwick. Select the wrong statement for the neutron. Neutrons are electrical neutral, correct. Two neutrons inside the nucleus expend nuclear force, correct. Two neutrons inside nucleus expend electrostatic force, that is incorrect. This is the incorrect statement. Neutron is stable inside the nucleus and free neutron outside it is unstable, it is also correct. According to Einstein, E is equal to mc square. Energy equivalent of 1 kg mass is, that is 9 into 10 to the power of 16 joules. Energy equivalent of mass defect of nucleus is called as binding energy. That is EB is equal to, it is delta M C square. According to binding energy curve, which of the following element is less stable? Less stable elements with the less mass number, they are less stable. Therefore, this is a correct one. Binding energy per nucleon is the ratio of binding energy of the nucleons to the mass number, that is EB by A. That is correct one. Select the true statement. Nuclei having highest binding energy are more stable. Okay, that is not true. Nuclei having least binding energy are most stable, that is not true. Nuclei having highest binding energy per nucleon, that is the iron is most stable. It has a value of 8.85 mega electron volt of energy, that is specific binding energy, therefore it is most stable. Okay, next question, question number 35. Which of the following particles cannot experience nuclear force? Okay, nuclear force is experienced by the particle present inside the nucleus. This will experience neutron, proton, 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 experience electron, proton. There will be a electrostatic force. Therefore, this will be the correct answer. Select the statement which is not true. Nuclear force is short range and saturated. That is correct one. Nuclear force can exist between the electrical neutral particle. That is correct. Nuclear force is charge independent, strong and for correct. Nuclear force varies square of the distance. That is incorrect. Okay, next question. The force that acts like centripetal force for the electron revolving around the nucleus, that is electrostatic force. Radioactivity was discovered by Henry Becquerel, which is not found during radioactive decay. Emission of alpha particle, that is alpha decay. Emission of beta particle, beta decay. Emission of X-rays, it is not found. Emission of gamma rays, it is gamma decay. Alpha particles found during the radioactive decay process are positively charged because alpha particles are nothing but helium nuclei. Alpha particles found during radioactive decay process contains 2 proton, 2 neutron, 2 protons and 2 neutron, 4 minus 2, that is correct. Beta particles found during radioactive decay process, they are beta minus, they are negatively charged particle, they are electrons. Beta plus found particles, they are called as positively charged, that is positive electron. Gamma decay radioactive involves electromagnetic radiation, that is gamma photon. After alpha decay of the radioactivity as compared to parent nucleus, so there will be a helium particles emitted. Therefore, mass number of the daughter nucleus decreases by 4 and the atomic nucleus decreases by 2 units. Okay, next question, question number 46. After beta decay of the radioactivity, atomic mass number of the daughter nucleus increases by 1 and mass number remains same, that is negative beta decay. Positive beta decay, atomic number of the daughter nucleus decreases by 1, mass number remains the same. Okay, during gamma decay of the radioactive substance, there will be no change in the mass number and no atomic number. In beta minus decay of the radioactivity, a neutron transferred into proton within the nucleus. That neutron transfer into proton and electrons emitted and antineutrons emitted. Therefore, option A is the correct. Beta plus decay, a proton transferred into neutrons inside nucleus. Proton to neutron plus positron plus neutron. Therefore, option B is the correct one. Name the particle X in the following. Yeah, neutron, it converted into proton plus electron. Therefore, the particle is antineutron. I have written here. And here for this reaction, neutrino will be the correct answer. Which of the following particles emitted along with the electron in beta minus decay? During beta minus decay, antineutrino is emitted. The charge on the neutrino is, it is 0. It is a neutral particles. Charge on the antineutrino is also 0. Okay. Next question. Rate of disintegration of the radioactive sample, it is directly proportional to number of atoms present in the sample. That is radioactive decay. dN divided by dt is proportional to n. dN by dt is equal to minus lambda into n. Negative sign indicates that as time increases, number of atom decreases. The time in which the number of radioactive nuclei disintegrate to half of the original value, they are called as half-life. The time in which the number of radioactive nuclei disintegrate to e to the power minus 1 times the original value, that is called as mean life. That is 1 divided by e times the original value. With reference to radioactivity, select the correct statement. So always mean life is greater than the half-life. Relation between the mean life and the half-life is, that is mean life tau is equal to t divided by 0.693. T divided by 0.693. Relation between half-life and decay constant, that is T is equal to 0.693 divided by lambda, that is option A. Relation between mean life and the decay constant, that is Tm is equal to 1 divided by lambda, that is option C. Reciprocal of decay constant is called as mean life. SI unit of radioactivity is becquerel. 1 curie is equivalent to 3.7 into 10 to the power of 10 becquerel. The process in which two daughter nuclei combine together to form heavier nuclei is called as nuclear fusion. During nuclear fission process, mass is converted into energy. Okay, next question number 68. In nuclear power reactors, controlled fission chain reaction is undertaken. Okay, it can be controlled. In nuclear bomb, it is uncontrolled fission chain reaction is carried out. Nuclear reaction occurring in a star is called as fusion reaction. For the nuclear reaction occurring in a nuclear reactor, multiplication factor K is equal to 1. Okay, which of the following is also called a thermonuclear reaction, that is fusion reaction? It need high temperature. In a nuclear reactor, moderators are used to slow down the fast neutrons. In a nuclear reactor, control rods are used to absorb the neutrons. Thank you. Please subscribe Southern Pathshala for more such videos.